Good evening, everyone. My name is Mark Harris. This is my colleague, George Stohan, and this is our Antico Cafe Greco performance analysis. Before we begin, we wish to briefly unpack a little bit about ourselves so that you get a better sense of who we are as individuals outside of contracting. I am a native of Chicago, Illinois. I am a data science by training, but more so of a strategist. I am also a second-year MBA candidate at Carey Business School at Johns Hopkins University.
Hi, everyone. I'm George Stoyan. I'm also a second-year MBA candidate, originally from Serbia, a rheumatologist by training, and currently in the pharmaceutical industry, working in medical affairs.
And so we'll just jump right into it. So our bluff is as follows. We wish to implement a single solution that includes a combined solution of merging the three dedicated queues into one pool queue system. Our contention is that by doing so, this approach is estimated to reduce the average customer wait time from 4.9 minutes to just shy of under 2 minutes, so approximately a 60% reduction. Our contention posits that this solution provides the best balance of significantly improving the key performance indicator of customer wait time while keeping incremental costs reasonable. So the current system analysis, after reviewing the current system analysis, ACG currently has 3 baristas, each with their own queue in a Victoria Arduino Venus semi-automatic espresso machine. Customers arrive at each queue according to the passing process with a rate of 38 per hour. The service time for each barista follows a normal distribution with a mean of 90 seconds and a standard deviation for 20 seconds. Looking directly at the queuing model, a MMK model used for analysis was instituted. The inputs are for the arrival rate is 38 customers per hour, the service rate is 40 customers per hour, and the number of baristas were 3. After reviewing the current system analysis, we were able to identify some key findings. The current dedicated queue system results in an average customer wait time of 4.9 minutes. High utilization of 95% is likely contributing to the long wait time. This, in turn, indicates a significant room for improvement.
So as far as recommendations on how to fix the long waiting times and high utilization rate, we implemented 4 strategies. The first one was pooling the queues, meaning we wouldn't use separate queues for each baristas, but all patients that come in are served by all 3 baristas at the same time. The second model was increasing the number of baristas from 3 to 5. The third one was reducing service time variability through training. And the final one was introducing an automated machine. And the way that we did this was assuming that all 3 baristas would be replaced by a machine, whether as a separate queue, meaning that there's still 3 separate queues, or whether everyone would be pooled in one. And as far as the key findings, you see on the right-hand side, the pooling queues gave the highest wait time reduction. So it went down from 4.98 minutes to 1.51 minutes. The reduced variability model really didn't change much at all compared to the baseline model. The added capacity did make a difference. So adding 2 baristas decreased the waiting time to approximately 3 minutes, but not as much as pulling the queue. And the automation model technically didn't make any difference as far as baseline model in case there was a separate queue, or versus the pooled model if we pulled all 3 and if we pulled the 3 into one queue. So it was 1.5 and 4.95 minutes. And obviously this would incur quite significant cost. So looking at the results of the simulation models, our recommendation was to merge the 3 queues into a pooled system. As far as the strengths of the approach of this analysis, it's a data-driven analysis and a quantitative modeling. And the proposed approach significantly reduces the wait times. The weakness is that the model is dependent on the assumptions and on the accuracy of the data, but this can't be addressed by real-world observations over time. As far as the opportunities, improved customer satisfaction is of paramount importance. In the case, we saw that the location of ACG is between some very high-end stores. So these are likely customers that in whom a very high wait time can have a significant psychological impact and reduce the likelihood that they return as customers. Also, this would increase the revenue potential with greater customer volume. As far as threats, there's always practical challenges in how this would be implemented, and there's real-world variability that may differ from the models that we use. So in conclusion, the current operational design with the 3 dedicated barista queues results in very long customer wait times of around 5 minutes on average. And we thus recommend, based on the analysis we performed, to merge the 3 queues into a single pooled queue system. This combined approach would reduce the average wait time to under 2 minutes, which is a 60% improvement. And I think this concludes our presentation. Mark, anything we need to add at the end?
No, I would just say if there are any other questions regarding the simulation model, we would like to refer you to our appendix session in the analysis.
Yes, correct. So we included screenshots of all the different simulation models in the appendix. And if there's any questions, please reach out to us. We're always available.
Yes. Thank you so much for your time and consideration.
Thank you. Thanks, Mark.
Thanks.
Now, if only I know how to stop the recording. I hope this doesn't affect our grade, will it?